beautiful people, and welcome. In today's video, we're going to talk about how to determine if a function is even or odd, or neither. It can be even, odd, or neither. As always, disclaimer time. If I make a mistake, I am human. Let me know where the mistake occurs so that way I can learn from my mistakes. All right, let's go ahead and get started. So we can do this in two different ways. So we can determine if it's even or odd, or neither. Let's write that in there. We can determine this graphically, or we can do it algebraically. So if we have a function that is already graphed and it's asking us, hey, determine if this is odd, even, or neither, there's two things we have to look for it. If it is an even function, even, let me learn how to spell even here quickly. So even functions, they have a graph that is symmetric with respect to the y-axis. What that means, or what it looks like, is that the y-axis it acts like a mirror. We're going to reflect across the y-axis. And if we have the same thing on the left-hand side of the y-axis and the same thing on the right-hand side of the y-axis, and it kind of mirrors each other, then you have a function that's even. For example, if I can quickly sketch this out, if we have a function that looks like this, here is my y-axis, here's my x-axis, and we want a reflection. We want a mirror image across the y-axis. So if I was to take this function, and flip it over, it's going to line up with the other side. So if I take this piece right here and flip it over, it's going to match up precisely. So the y-axis is acting like a mirror. So that's how we determine even functions. Now for odd functions, let's switch this up. So for odd functions, they have a graph that is symmetric with respect to the origin. Now what that means is, if you spin the picture upside down about the origin, the graph looks the same. So here's an example of an odd function. Again, if you spin the picture upside down about the origin, the graph looks the same. So let's do a quick sketch of an example. All right, here is an example. Where's our origin? Our origin is in the center, 0, 0. That's our origin. So if we take this function and we start rotating it, and keep rotating it, it's going to end up lined up perfectly on top of each other. So it doesn't change in the rotation. So if you have that symmetric with respect to the origin, that means you have an odd function. Now, if you don't have something that is mirrored on the y-axis and you don't have something, or I should say or you don't have something that is symmetric with respect to the origin, if it's not one, not the other, then you have a neither situation. In this class, majority of the time, we're going to actually work with this algebraically. In my opinion, it's easier algebraically because you don't have to use your imagination. Unlike with these, you do have to use your imagination a little bit for your symmetric with y-axis and symmetric across the origin. All right, so this is actually, in my opinion, better, and this is algebraic test. So there are steps. Step number 1 is substitute a negative x in for every x and analyze the results. Step number 2, you have an even function if y is equal to f of x for each x in the domain of f of x. Okay, that sounds weird. Let me translate that for you. What we mean by that is if you get the same answer at the end. So if you plug in so when you plug in negative x and simplify, and you get the original function, you have an even function. And we'll do some examples. So again, so when you plug in negative x for all of your x's, and you're going to simplify, and if you get the original function after you have simplified and it matches completely, that means you have an even function. Now let's say if you have an odd function, it is odd for when f of negative x, excuse me, is equal to negative f of x. What this means is after you plug in negative x for all x's, excuse me, you simplify, and you don't get the original. Oh, you guys can't see what I'm writing. You don't get the original function. You get the odd or the opposite of the original function. Simplify, and you can factor out a negative. And so what you're going to get is a negative times your original function. If you have this, a negative times your original function, that means the function itself is odd. And we'll do some examples. And of course, just like graphing, if it's not this one and it's not that one, or again, I did it again with my ands, if it's not this one or it's not this one, then it's neither. So let me do an example, one of each, to show you what this means. So let's do example A. F of x is equal to x squared plus 4. And again, we need to determine if this function is odd, even, or neither. So step number 1, I'm going to replace x with negative x. So here I have now f of negative x is equal to, and always use parentheses. If you don't use parentheses, shame on you. You got to use parentheses. We're going to replace it with negative 4. So, with negative x. Here it is, negative x. Next thing you know, we're going to simplify. But don't simplify your function notation. This means nothing. This just means that we are evaluating the function using negative x. So don't simplify anything on the left-hand side. But on the right-hand side, we need to simplify something because this means we have negative x times negative x plus 4. Well, negative x times a negative x, what is a negative times a negative? Well, that's just a positive. So this means I have x squared. The same thing because negative and negative is a positive. Let's actually do it this way. I'm going to break it down with a few more steps. You don't have to. The same thing because they're both positive. So then I have f of negative x is equal to x squared plus 4. And check it out, you guys. Check this out. Do you see how after I simplified, I get x squared plus 4? And x squared plus 4 is the same thing as what we originally started with? That means, where the magic happens, that means f of negative x is equal to f of x, and that means your function is even. Let's do another example. I'm going to separate it out with the squiggly line. We got f of x is equal to x cubed minus 2x. I'm going to not write out the steps. We're just going to go ahead and do it. Step number 1 is to replace all of your x's with negative x. So I'm going to say negative f of x. I keep saying negative first. It's f of negative x. F of negative x is equal to negative x cubed minus 2 times negative x. Okay, if I have a negative value here and I cube that value will remain cubed. For example, negative x times negative x times negative x minus 2 times negative x. This right here, this will always be negative because if you do negative times a negative, that's positive. And then a positive times a negative, that's negative. So this will always be negative. So we're going to go ahead and say this is the same thing as saying negative x cubed. Now, notice there's no parentheses. That means we're taking it this way. This will always be negative. And then we have our minus 2 times a negative x. Well, I have a negative here and a negative here. Two negatives make a positive. So I have negative times x cubed plus 2x. So once we're here, I have to ask myself a question. Like, it can't be simplified anymore. We've simplified everything. And we're trying to see if it matches. If it matches, that means I have an even function. If it does not match, it can be a neither function or it can be an odd function. We just need to see if we can factor out a negative. So I'm looking here and I see x cubed is what I have. I have the opposite of that. I have a negative x cubed. Okay. Next thing I have is a minus 2x. I have a plus 2x. Notice how for each term, what I have right now is the opposite. And because every single term is opposite, I can, in fact, factor out a negative. So I'm going to factor out this negative. That means I have an x cubed left over and a minus 2x. Notice at this point, after I have factored it out, here's my f of negative x with my negative here. And then here is my original. Notice that the original and the after match once I have factored out my negative. So that means this right here is a negative f of x. So f of negative x is the same thing as saying negative f of x. And that means we have an odd function. All right, let's do one more example. We have f of x is equal to x squared minus 3x plus 4. Always start with replacing f of x with f of negative x. All of your x's are now becoming negative x's. When we have x squared, but it's negative x, negative times a negative is always a positive, so this becomes simply x squared. I have a negative here and a negative here. Negative times a negative is a positive. And I have a plus 4. Okay, so again, 3 options. Even, it matches identically with the original function. Odd means it matches, but all of the terms are opposite. Neither is, it doesn't match at all, and the signs are way different. So let's see, does it match completely? Well, x squared and x squared, they match. I have a negative 3x in my original and have a positive 3x in my my other one, my f of negative x. So these are opposite, these are the same, and these are the same. So I have same, opposite, same. So because it doesn't match perfectly, so it's not odd, excuse me, it's not even, and all of the terms are not opposite. We only have one term that's opposite, so it's not odd. So we have an even, a neither function. Again, odd, all of the terms have to be opposite. Even, all of the terms have to match. Neither means it's not odd and it's not even. All right, beautiful people, this wraps up this video. If you have any questions, please reach out. Thank you so much for watching, and I will see you in my next video.